Now, this illustration deals with system grounding connections in accordance with NEC 250.24a. Now, notice 250.24a makes it very clear that the grounded conductor in the service equipment from the transformer has to connect to a common bar or two bars made common, bonded to the enclosure of the service equipment as you see in the illustration. And then notice that we have a main bonding jumper there. It could be a screw, a strap, a conductor, and so forth. And then notice all your equipment grounds and your neutrals as outlined in 250.122 and 220.61 will connect to that common bar where the grounded conductor from the supply side is connected, along with the grounding electrode conductor connected to the electrode system. In this case, we just show a driven rod, and we list 250.52A5, 250.53A, 250.53G is loaded with information about that driven rod. And notice the grounding loop. Table 250.66 only sizes the grounding electrode conductor if you connect it to structural steel or a metal water pipe that is identified as an electrode in accordance with 250.52. But if you had a driven rod, as you see, that's 250.66A, the second bullet in the grounding loop. B would be if it was a concrete encased electrode, and it'd be number 4. And C would be a ground ring encircling the building, would be, number 2, maybe. But what I'm pointing out, you only use table 250.66 if the grounding electrode conductor connects to structural steel or a metal water pipe. Or other words, you use 250.66A through C. Now, table 250.102C1 sizes the grounded conductor you see in the piping system at the service equipment. And notice that grounded conductor could be a neutral. 250.142A1 said it's supply. And it's sized from our table 250.102C1. Now, I'll use the same example size conductors that we've been using to be as consistent as possible. But say you had 4-aught ungrounded service conductors connecting to a 225 amp main. Then based upon 4-aught, using table 250.102C1, it'd have to be number 2. All the grounding in there would be number 2, except the grounding electrode conductor to the driven rod. It would be number 6 then, see, because it's 250.66A that you would be using. But everything else would have to be the same size, except your equipment grounds coming in, terminating to that bus bar. And they would be sized upon the overcurrent device ahead of the branch circuits that they are routed with. Now, the next thing, 250.104A through C, deals with electrodes and piping that is not considered electrodes. Now, we'll get into that as we get on into the grounding chapter. 250.50 deals, with enclosures and things that have to be bonded. 250.52A1 through A7 deals with items that can be considered electrodes, like 10 feet or more water pipe in the earth, electrode. A driven rod, electrode. Concrete encased electrodes. So it describes how they have to be material-wise, length-wise, and shape and so forth to be considered an electrode. That's found in 250.52A1 through A7. Electrodes that have to be bonded together in accordance with 250.50. Now, 250.53A through H deals with installation. So basically speaking, 250.50 says your electrodes, all of them, of A1 through A7 to 250.52, if present, have to be bonded together into an electrode system. Then if you look at 250.52, that section describes what is considered an electrode. 250.53 is what the electrician uses to make the installation. 250.50 A and B deal where systems have to be grounded or they do not have to be grounded at 1,000 volts or less than 50 volts. And then if we look at 250.21, those systems you have a choice. You can ground or you don't have to ground. And remember, 250.22, those systems you cannot ground. Those three sections you should always remember. There'd be 6 there. But if you're grounding, and you do a lot of grounding, you should know those, or at least know how to go and look them up. You understand? And then 250.60 deals with lightning protection. 250.64 A and B deals with a common grounding electrode conductor in some cases, with taps and so forth. So those are major loops depending on how you're providing your grounding electrode or grounding electrode systems and sizing your grounding electrode. Now to the right, we show the service equipment. Could be a switchboard, panel board, even a switchgear. We identify the grounded neutral conductor, and 250.142A deals with supply side grounding, meaning no overcurrent device ahead of your conductors. 250.142B deals with load side grounding, meaning there is an overcurrent device ahead of your conductors. And then we show the bus bar there that is grounded in accordance with 408.3C as in car. And then the material that the main bonding jumper can consist and be is green in color if it's a screw, it's attachment, sizing, and all that's in 250.28A through D. So major sections are listed here. A lot of times people say, well, there's nowhere in the code that says a transformer outside has to be grounded. Yeah, it's required to be grounded in 250.24, A as in apple 2.